Hello, welcome to Functions, Day 7. Today we're going to talk about parametric equations and curves. And so we're starting off with an example here. So the example is that there's a rock dropped from a 420-foot tower, and the height above the ground after so many seconds is modeled by the equation y equals negative 16 t squared plus 420. So first thing we can do is just find the rock's height in feet for the given time value. So say at 0 seconds, obviously if we put 0 into our equation, we get 420. After 1 second, put 1 into the equation, 404, right? And we could keep putting in every 1 second intervals, right? And we're at 5, right? We're at 20, so it's pretty close to hitting the ground at this point, okay? And so that's one way to kind of describe this, what's happening with this rock. So since the rock is dropped from the tower, we can imagine that the rock's fall is on a vertical line, kind of as you see on the picture. So if we say that the equation for the vertical line is x equals 2.5, right, then what value do we have for x at any time value? Right, so 2.5, you can kind of think of a 2.5 as like the distance it is away from the building, right? So because it's falling straight down, it makes sense that the distance away from the building, no matter what time has elapsed, is always going to be 2.5 feet, okay? And then we could put those two ideas together. We could say, well, after this many seconds, right, it's 2.5 feet away from the building and 420 feet up, right? After 1 second, it's 2.5 feet, 404 feet up. And so what we can do is we can use these two equations, x equals 2.5 and y equals negative 16t squared plus 420, and we can use those to describe this application of this rock falling. These two equations are called parametric equations. Parametric equations are basically, you're given two equations, an x equals and a y equals, and both of those equations are in terms of a third variable t. Now for this example, the x equation did not have a t in it. That's okay. It's still a parametric equation. So what we can do is we can graph parametric equations. So we graph the ordered pairs x, y, where x is a function of t and y is also a function of t. And we call this interval, so we graph the x and the y on this interval of t values, and that's called a parametric curve. All right, so let's look at the example on the top of the next page, number 1. So for the given parametric equations, we're going to fill in the table and plot the points x, y on the coordinate plane and identify the graph. So what we have here is we have x equals 1 minus 2t is one equation, and y equals 2 minus t is the second equation. So as we can see, we have an x equals, a y equals, and both of those have the input variable of t. Now, for this one, it says for an interval of t is greater than negative infinity and less than infinity. So basically that means all values of t. So the purpose of our table, we just pick some values of t that we knew when we plugged in, we would get some points that were going to be on our grid here. So we picked values from negative 2 to 3. So all you have to do here is just take negative 2, plug it into the equation here for t. So 1 minus 2 times negative 2, so that's 1 plus 4, so you get 5, right? And you continue doing that, put negative 1 in here for t, you get 3. Put 0 in, and so on, right? So we can easily get the table of values for x just by substitution. We do the same thing to find the y values. So we take negative 2, we sub it into this equation. 2 minus a negative 2 is a positive 4, right? 2 minus a negative 1 is 3, and we can get the rest of our y values. And then all we have to do is we just have to plot these x, y points. So we're just going to plot 5, 4, 3, 3, 1, 2, negative 1, 1, negative 3, 0, and 5, negative 1, and connect, and we get a nice straight line. We would put arrows on our graph because of our defined t as being from negative infinity to infinity. Look at number 2. So go ahead and get your graphing calculator out if you don't already have it next to you. And what we're going to do, so that what we just did, that's basically the idea, is you put in your values, you get your table of values, you draw your graph. It can be pretty time consuming and kind of not fun to just keep putting in values. So we're going to show you how to use the graphing calculator to make it a little bit easier. So I'm going to switch over to the graphing calculator here. So first of all, what we want to do is we want to change our calculator to parametric mode. So remember we changed it to polar mode before. So if we go to mode, you will go here and you will see, right, that we have function parametric polar. So what we're going to do is go down and put it in parametric mode. There we go. We can quit out of there. And now when we go to the y equals key, right, we will see, notice what I had in there before, that we have x equals and y equals, right? So that represents one equation basically, right? And when we type in our variable, we get a t rather than an x or a y, or a theta or whatever else we were doing before. So our first equation we're going to put in is t squared minus 3. That's for x equals. Then we have y equals 2 times t. Okay, and so we have our two equations set up. Now, there's a few things that we're going to have to do. So we want to go to our table. So one of the things we want to do is copy our table down. So we're going to go to second window because that's our table setup. So we want to start our table. If we look, our t values are going from -3 to 3. So we want to start our table at -3, and we were increasing each time by 1. Okay, so that's the first thing we can do to make our lives easy is we can find our table values. So now we go to second table, and oh my, we have all our values. All we have to do now is write them down. So we'd write 6, -6, 1, -4, right? All the way up to 3 here. Okay, so that's the first thing we do is we can fill in our table, right? Then we could plot our points. The nice thing also is that we can look at what this looks like on the graphing calculator. So we could do a zoom standard, and I don't know what will happen. Yeah, we get this weird kind of looking thing, and we're like, I'm not sure about that. So what we have to do is we have to go to window, right? And in the window, you notice here that it has T-min, T-max, right? T-min and T-max should always match whatever the interval has. So if we look back at our problem, right, our interval was saying start at -3, end at 3. Okay, so when we're in our calculator, we want our T-min to be -3 and our T-max to be +3. Okay. T-step then is how often is it going to plot a point. The smaller T-step we have, the more points we have and the smoother the graph will be. Now you don't want to go too small because then it might slow your calculator down and kind of freeze it up. So let's just try 0.1 and we'll see where that goes. So x-min, x-max, y-min, y-max, those can stay -10 to 10, -10 to 10. That's what the graphs that we're giving you. So those should stay there as well. So now if we hit graph, right, we get this beautiful sideways parabola, right? And if you go and look at your table of values, right, you will notice, right, that our value here is at 6, -6. This value here is at 6, 6. And then if you plot all your points. So we do want you to graph it by hand as well. Okay, so you're going to use the calculator to your advantage to help you come up with your table, right? And then you're going to use those points to draw your graph, right? And then the nice part about the calculator is you can check your graph, right? Do you have the correct shape? Do you have the correct starting and stopping points? Okay, so the x-min, x-max, y-min, y-max, that just sets your x and y axes. So just leave those at -10 to 10, -10 to 10. T-min and T-max, that sets our range of T values. So you're always going to say go from the smallest value, that's going to be your T-min, so -3 here, and then T-max would be 3. T-step is your increments of T. Obviously, the smaller the T-step, the more points, the smoother graph. The larger the T-step, less points that we have. We can kind of just show that idea here if we go to our T-step, and let's say we just do it every 1. And let's see what the graph does, right? Look how it's not nearly as smooth, right? It's just it's just connecting point to point and not drawing all those smooth points in between. I think would be a good thing for you to do is to pause the video and go ahead and try to do numbers 3 through 7, so the rest of the problems in the packet here. So see if you can put those in your calculator, adjust the window for the T-min and T-max, and see if you can draw the graph. Okay, so I'll give you some time to do that. When you come back, when you unpause, I will go through those solutions with you. Welcome back. So hopefully you had some fun playing around with your calculator. So I'm just going to go ahead and go through the solutions. I'm going to kind of show you what they look like on the calculator as well. So here is our table. So again, if you need to pause it to check your answers, go ahead and do that at any point during this. So number 3, we end up getting something that looks like our cubic that we had from earlier in the year. And so let's go ahead and put our two equations in. So I have 3t and I have t cubed minus 2. All right, so let's go to our window. So here we wanted our t min to be negative 2 and our t max to be positive 2. Oops. And let's change the t step to make it much smaller than 1. Let's do 0.1. Okay. Let's go to our graph, and we get the same kind of graph that I had on my picture, right? So again, so that's what your graph should look like, right? If you go to your table of values, again, you know, the table setup kind of tells you where to start and how many to go. If we started at negative 3, it's okay, because, you know, we just have to know, well, we're just starting at negative 2. We're just going to write those points down. So this is where you found your points, right? And then here is what your graph looks like. All right, for number 4, we should end up getting a circle. And we had lots of points that we had to write down for this one. But let's go ahead back to the calculator and let's put this in our calculator, and we'll go from there. 6 cosine t and 6 sine t, our window. So in this case, our t was going from 0 to 360, right? And we probably don't want to go every 0.1. I'm going to try 1 and see how that goes. And we'll see if it graphs it. So there we go. So we got our graph. Now again, remember this kind of idea where we had before with polar, where it ended up looking kind of out of sorts. Doesn't quite look like a circle, and that's because we might want to square it up. Okay, so if you get a shape that looks kind of weird, not quite like what you have on your grid, do the zoom square and see if that works. And then again, right, the easiest place to find our values, so if we go to table setup and we say start at 0, and if we look at our table, it was going every 15 degrees, right? And then so you want to always go to that table setup, put in that first value, put in the increment, right? And then when we go to our table, right, it's not like we have to put all these values in ourselves. All we have to do is write them down from the table of values. Okay, so here are our solutions for number 5 and 6. Number 5, again, we get another circle, right? So again, you put your two equations into your calculator, do your table. So this table, you're going to start at 0, going by 30 degrees, right? T min is 0, T max is 360, so that should be the same as last time, and you get a circle. Number 6, you get kind of this cool bow tie shape. So when you put your two equations in and do your table, so in this case, you're going to have the same table set up that you had in number 5, and you should have those same values that work there as well. So that's kind of a fun looking shape that we have. Again, if you need to pause the video at this point, go ahead to check your answers, and then I'm going to go over number 7 here. 7 turned out to be a really cool looking graph, right? It looks like kind of this cool basket weave. And you might ask yourself, Mrs. Fleming, how am I ever supposed to draw that? That's impossible. So let's go ahead and look at that in the calculator, and I'll kind of show you some tricks for doing that. Two equations, 5 cosine of 3t and 5 sine of 5t. So we can go to our table setup and make sure, so 0, and we want to go by 30, which you probably already have in yours. I just didn't do the last one. Then we could go to our table, and we could write our interesting points down, right, all the way up to 360. And then we could look at our window, and 0 to 360, t-step of 1. Okay, so let's see what that does with our graph. And we get the really cool shape. And you still might ask yourself, well, how do I do that? How do I create that? Or do I just kind of guess? Well, you could just sort of guess, but that's not really the fun part of it. So one of the things that if you slow down your graphing, so if we go to window and let's try putting this at 0.1 and see how it does. And when we hit graph, so one thing we can do is we can stop our graph while it's graphing. So if I hit graph and I hit enter, it stops my graph. If I hit enter again, it keeps graphing, right? So what I could do is I could say, okay, I'm going to plot 5, 0, right? So I'm going to plot 5, 0 on my graph, right? Then I'm going to plot 0, 2.5, right? And then I look at my graph and say, oh, well, I go up and down to there, right? And then I do -5, -4.33, right? And so you can start and stop your graph just by hitting enter. You have to have a small t step in there, right? But if you do, right, then you can slow your graph down and you can kind of do each point and then plot your point. So it's kind of a cool way to do it, and it's kind of a nice feature to know that you can hit that enter button and it can stop. And if you just let it keep going, right, it'll just keep drawing it. So the smaller the t-step, it slows the graph down. Like I said, you don't want to go too small to make it totally freeze up. But that is our graph.